Next, we're going to look at number 25 from section 3.2, which is very similar to number 24. Those same students, in their project, they also tested 118 students who had stuffy or runny noses with the same Skittles taste test. So they were looking to see whether having a stuffy or runny nose might affect somebody's ability to correctly identify the flavor. So the observational units are the 118 students that were tested, and the variable and the type of variable are the same as they were in question 24. So now we want to find and interpret a 95% confidence interval for the proportion of all students with stuffy or runny noses that could correctly identify a Skittles flavor blindly. So keep in mind, we collected data from a sample of students, and we're going to use that sample proportion of success to come up with an interval of plausible values for the parameter pi. So in this case, we need to figure out our p-hat value, the sample proportion of successes in the sample. 44 out of 118 students correctly identified the Skittles flavor, and that was 0.373. So just common sense wise, in the previous question it was about half the students correctly identified the flavor. In this question it's less than 40%. So there does seem to be a difference when the students have stuffy or runny noses that they can't identify the flavor as well. Okay, and to find the 95% confidence interval, this is going to be very similar to what we did in question 24 in the previous example. So we're going to take our statistic, has to be a decimal, plus or minus the multiplier 2 because we're doing 95% confidence, times the square root of our p-hat times 1 minus p-hat all over the sample size, which in this case is 118. So again, I strongly encourage you to pause the video and make the calculations. So first figure out the square root value, and when you do that you should get 0.045. Right, and I would take this step by step. Next thing is to multiply the 0.045 times 2, and that of course gives 0.09. So at this point our confidence interval is in the form statistic plus or minus margin of error. So again, the 0.09 is the margin of error. And now, with the plus or minus, we're going to split this into two calculations. So first we're going to do 0.373 minus 0.09, and then we're going to do 0.373 plus 0.09. And again, pause the video and do this for yourself on your own calculator. When you do the subtraction, you should get 0.283, and when you do the addition, you should get 0.463. And that is our 95% confidence interval. And I pre-made the sentence for the interpretation. We could just fill in the pieces. So we are 95% confident because that was our confidence level. That again, we're describing the parameter, the proportion of all students with stuffy or runny noses that could correctly identify a Skittles flavor blindly, is between 28.3% and 46.3%. So again, I'm converting. You could write the decimals as well. You could say is between 0.283 and 0.463, and there's nothing wrong with that. But when we make an interpretation, we want to make it as understandable for the average person as possible. And the average person probably has a better handle on the percents than they do the decimals. Right? And once again, I just want to emphasize, we started with a sample proportion from 118 students, and now we've created this interval that is estimating pi. So we still don't know the value of pi, but now we've narrowed it down that plausible values are somewhere between 0.283 and 0.463. And then let's go back to the applet and update it for this new sample. So out of 118 students, 44 of them could correctly identify the flavor, and notice the computer has automatically created the p-hat value, and the bar graph has not updated until we click calculate, but the confidence interval has updated automatically to 0.2856 up to 0.4601. So that's the theory-based interval. So the theory-based confidence interval is 0.2856 up to 0.4601. So again, notice it's similar to the interval we got with our own 2SD method. The reason why they're a little bit different is because the multiplier in the theory-based is not 2, and there's also a little rounding error there, right? And again, we really should note that the validity conditions are met. So it's okay to use a theory-based, and that's actually one of the reasons why the theory-based and the 2SD are so similar. It's okay and valid and proper and appropriate to use the theory-based method because the validity conditions are met. There are 44 successes. And again, we have to do a little backwards calculation. Let's see, how many failures would that be? So 50, 68 plus 6, is that 74? I believe so. I just did that in my head, so I could be wrong. So again, better to say how many successes and failures you have rather than just saying, yes, the conditions are met. We have at least 10 successes and 10 failures. In fact, in this case, we have 44 successes and 74 failures.